Good evening. We're on day 2 of the Unit 8 packet. Tonight's lesson is to learn how to find the slope of a line and to use the slope of that line to draw a graph. The first thing I want you to know is that by definition, the slope of a line is the change in the y direction of a line compared to the change in its x direction. Sometimes the change in the y direction is called the rise, because when we go up and down, like on the y-axis, we rise. We start here and we rise. Change in the x direction is sometimes called the run. Think about running back and forth on the ground, which would be the x direction. So that's this direction is the run, and this direction is the rise. If I want to calculate the slope of a line, I can do that with a formula. Like pretty much everything else in math, there's a formula for doing it. I'm going to zoom out here for a second. So what I need to do to calculate the slope of a line is pick 2 points on the line. Remember, we express our points as ordered pairs, x being first, y being second. I'm going to pick the first point on the orange line is 1, 2. That's the first point I'm going to pick to use. The next point I'm going to pick is the point at the origin, 0, 0. So to calculate this, all I need to do is subtract the second y value from the first y value. And that's going to give me the change, right? I'm going to write a little setup like this, draw an arrow here to show that I'm doing calculations for the y value. 2 is the original y value, right here. 0 is the second y value. So I can say 2 minus 0 equals 2. So the change in the y direction, I can say, is 2. To do the same thing for the x direction, I'm going to subtract the second point from the first point. So 1 minus 0 equals 1. So the slope is 2 over 1. But we don't need to show the 1. Remember, guys, if it's 2 in the denominator, we don't really need to show that. So I can just say that the slope is equal to 2. Just a minute, guys. Let me get this phone call. Okay, I will. Okay, so I had a caller, and the caller asked me, well, Mrs. Pritchard, you picked these 2 lines on the x-axis, on the coordinate plane. You picked 1, 2, and 0, 0. But there's other points. Could I pick other points on the line to calculate the slope? And the answer is yes. You can pick any 2 points on this line that you want to pick. You can pick those to calculate the slope. So let's use the original point, 1, 2. And then we'll go down here and use this other point, negative 1, negative 2. And we'll do the same calculation that we did before. And we'll see if we get the same answer. So, our new first point is 1, 2. And the new second point is negative 1, negative 2. 2 minus negative 2, right here. I know that by subtracting, I'm really adding the opposite, so I can switch both of those signs to positive. So 2 minus negative 2 really equals 4. On the x coordinate, 1 minus the negative 1. See if I can pan down a little bit. There we go. 1 minus the negative 1 can be changed to 1 plus positive 1 because we're adding the opposite. So 1 plus 1 equals 2. And we have the ratio 4 over 2. So the change in y is 4 over the change in x is 2. But that comes out to be 2, a slope of 2, just like we had before with the other point. See how that worked out? We used 2 different points. We used the same method for calculating the slope, and we got the same answer. Slope of 2 and slope of 2. My main point in showing you this is so that you know you can pick any 2 points on a line, any 2 points, and you should be able to calculate the slope and get the same answer. Another question that you may have about calculating the slope is, does it matter if I subtract this point from this point? Or do I always have to do this point from that point? And the truth is, it doesn't matter which point you choose as your first point. So let me show you that. calculate the slope. This time, the first point I'll pick will be the negative 1, negative 1. And I'm going to subtract 3, 1 this time. Remember, I'm showing you this so you know that it doesn't matter which point you pick as your first point. So, negative 1 minus a positive 1 for the x change, negative 1 minus positive 3. So minus 1 is negative 2, negative 1 minus 3 is negative 4. The slope is really, the negatives cancel out, and we simplify to the slope is 1 over 2, which is a half, which is what we got before. So the lesson here is it doesn't matter which point that you choose first. There are 4 kinds of slope. There is a positive slope of a line, where when we move in the x direction, in the positive x direction, we move in the positive y direction as well, so we go up. We can have a negative slope. When we move in the positive x direction, we move in the negative y direction, we actually move down. We have a zero slope, where as we move in the x direction, there is no change in the y direction at all. So as we move along this line, this horizontal line, y never goes up and y never goes down. So there's no slope. The last case is the undefined slope, where there is never any change in the x direction. We only have change in the y direction. So positive slope, positive x results in positive y. Negative slope, positive x change results in a negative y change. Zero slope, where x can be anything and y will never change. It runs horizontally forever. And the undefined slope, where there never is any x change, only y change. You'll need to remember these 4: undefined, zero, positive, and negative slopes. What I want you to remember is the slope is a constant rate of change in a relationship. That means the rate of change is always the same. And the relationship we'd be talking about is that of the line. The linear equation has a constant rate of change. So if I zoom in a little bit, zoom in a lot. Let's zoom in a lot. Okay. So if I move over 2 steps in the x direction, I will move up 2 steps in the y direction. If I move over 2 more steps, I will move up 2 more steps. And if I had those marked, if I moved over 2 more steps, I would move up 2 more steps. The rate of change is always the same with a linear equation. Now look at this one over here. Well, we can see right away this is not a linear equation. So the rate of change from one x unit over is not the same here as it is here. The change is different. In fact, it would be going down. If we keep going in the x direction, we see that the change is different again and different again. I'm going to wrap this up because I'm just about out of time. I'm almost at 10 minutes. So tomorrow on the daily quiz, and I will ask you this tomorrow on the daily quiz. I repeat, I will ask you this tomorrow on the daily quiz. I will give you these 2 graphs, and I will ask you which one shows a constant rate of change. And I'll tell you the answer now is the line. The line shows a constant rate of change. The squiggle does not. I repeat, this will be on your daily quiz tomorrow. See you tomorrow.